single output line. Multiplexing follows many to one, that is n input lines and one output line. Whereas demultiplexing is achieved by using a device called demultiplexer available at the receiver end. Demux separates a signal into its component signals. That means one input and n outputs. Therefore, we can say that demultiplexing follows to one-to-many approach. Demultiplexing is a technique used to combine and send the multiple data streams over a single medium. The process of combining the data stream is known as demultiplexing, and the hardware used for demultiplexing is multiplexer. Transmission media is used to send the signal from sender to receiver. The medium can only have one signal at a time. When multiple signals share the common medium, there is a possibility of collision. Multiplexing concept is used to avoid such type of collisions. Transmission services are very expensive in multiplexing, and in telecommunication, in which several telephone calls are carried through a single wire. Multiplexing originated in telegraphy in early 1870s and is now widely used in communication. The advantages of multiplexing is it uses more than one signal sent over a single medium, and the bandwidth of medium can be utilized effectively. Multiplexing is divided into three categories: frequency division, wavelength division, and time division. And in time division multiplexing, synchronous and asynchronous time division multiplexing is also found. This is the frequency division multiplexing. As this diagram shows, these signals are divided into number of signals. We call it division of signals as a channels. That means we say that the signals are divided into different channels. Both channels are combined into a single line, passed from multiplexer to demultiplexer, and at the demultiplexer end, these channels are again divided into different types of signals. It is as the signals are used in frequency division multiplexing, therefore it is an analog technique in which the available bandwidth of single transmission medium is divided into several channels. The input signal can translate it into frequency bands by using modulation techniques, and they are combined by a demultiplexer to form a composite signals. The main aim of this type of multiplexing is to subdivide the available bandwidth into different frequency channels and allocate them to different devices. Using the modulation technique, the input signals are transmitted into frequency bands and then combined to form a composite signal. The example of FDM is radio broadcasting and TV network. These are basically advantages, disadvantages, and applications of FDM. Now, second one is wavelength division multiplexing. Again, as the multiplexer and demultiplexers are used here, again the signals are transmitted into a multiplexer. Multiplexer combine both signals and generate a mixed single signal transmitted to demultiplexer. Demultiplexer again divided this single signal into different types of signals. Here we want a accurate result. That's why here fiber optic cables are used between the multiplexer and demultiplexer. It uses a fiber optic to increase the capacity of single fiber. It is used to utilize the high data rate capability of fiber optic cable. It is an analog multiplexing technique. Optical signals from different sources are combined to form a wider band of light with the help of multiplexer. At the receiver end, demultiplexer separates the signals to transmit them to their respective destinations. Prisms are also perform a reverse operation, that is demultiplexing the signal. Now the next one is a time division multiplexing. In TDM, we first divide the available bandwidth of the communication channel into time slots. Furthermore, we assign each input signal to a specific time slot. Therefore, the input signals are then transmitted sequentially, one after the other in their assigned time slot. It is basically a digital technique. It uses a user takes control of the channel for a fixed amount of time. In time division multiplexing, data is not transmitted simultaneously, rather than the data is transmitted one by one. The signal is transmitted in the form of frames. Frames contain a cycle of time slot in which each frame contains one or more slots dedicated to each users. Time division multiplexing is again divided into synchronous TDM and asynchronous TDM. This is a synchronous time division multiplexing. Each device is allocated with same time slot. These time slots are transmitted irrespective of whether the sender has data to send or not. Synchronous TDM is a technique in which each time slot is pre-assigned to every device. Each device is given some time slot irrespective of the fact that the device contains the data or not. If the device does not have any data, then the slot will remain empty. The disadvantages of asynchronous TDM is the capacity of the channel is not fully utilized, as the empty slots are also transmitted, which is having no data. Therefore, the speed of the transmission medium should be greater than the total speed of the input lines. An alternative approach to the synchronous TDM is asynchronous time division multiplexing. Now, this diagram shows the asynchronous time division multiplexing. It is also known as a statistical TDM also. In this technique, in which the time slots are not fixed, as in the case of synchronous TDM, time slots are allocated to only those devices which have the data to send. Therefore, we can say that asynchronous time division multiplexer transmits only the data from active workstations only. It is dynamically allocated the time slots to the devices. In asynchronous TDM, total speed of the input lines can be greater than the capacity of the channel. Each slot contains an address part that identifies the source of the data. And difference between asynchronous and synchronous is that many slots in synchronous TDMs are utilized, but the asynchronous TDM slots are fully utilized. This leads to the smaller transmission time and efficient utilization of the capacity of the channel. In synchronous TDM, if there are n sending devices, then there are n time slots. Whereas in asynchronous TDM, if there are n sending devices, then there are m time slots, where m is less than n. The number of slots in a frame depends on the statistical analysis of the number of input lines. Now come to the next point, demultiplexing. Demultiplexing is the reverse process of multiplexing. We use demultiplexing to separate the combined signal into their individual data streams at the receiving end. We can use specialized hardware such as demultiplexer IC to separate the input stream into multiple output streams. Additionally, we can utilize software devices to analyze the input data and determine which output channel it should be routed to. There are several types of demultiplexing, including 1 to 2 demultiplexing, 1 to 4 demultiplexing, 1 to 8 and 1 to 16 demultiplexing. Generally, we use 1 to 2 demultiplexing and 1 to 4 when the number of destination is limited and the signal routing is straightforward. However, for applications that require complex signal routing, we can use 1 to 8 and 1 to 16. This diagram shows how the demultiplexing can work. We can classify demultiplexer based on their construction, such as transistor to transistor logic and complementary metal oxide semiconductors demultiplexers. Thank you.